Okay, welcome back, everybody. We're talking about transformations, which are basically moves left and right and up and down and that kind of stuff. And we're going to do some graphing. If you have opened up the notes already, awesome. Then we're going to move this problem here up here. We're going to say that this is y equals the square root of x. All right. And this one, it's a little too easy. We're going to move this one over here and make it y equals absolute value of x minus 3, absolute value. And you just learned about making things flip, right? Reflections. So let's put a negative on the outside of this thing. So I'm going to erase my equal sign to make it really obvious and change the negative to a blue color. So y equals negative on the outside. All right, so that's going to be, hopefully you remember a few things about shifts and moves. All right, so anyway, just cleaning this up so that that's now over here. And you're going to be making an XY chart for that. So just a little bit of review before I give you that little quiz. We're going to do the first few questions here. Problem 1, problem 2, problem 3, and problem 4. All right, so here's your little review first. What if I had negative square root of x plus 6 and then a minus 9 on the outside? I want everybody to think about what 3 things would happen to my square root graph. And what does the square root graph look like in the first place? All right, so I'm going to give you I'm going to give you all 3. These are the 3 major kinds of graphs we've been talking about. There's that one, there's this one, and then there's this one. It's supposed to hit 0, 0. I just barely missed it. All right, so I hope you know which one this is, and then I hope you know that it's been moved left or right or up or down. So if I were in the room right now, I'd call on a few people. So I'm going to pause for a minute, and I'd like you to determine who in the room should answer for these 3 things that are going to happen, and which of them is it? Is it A, B, or C as the starting graph that's going to get moved this way and that way? All right, I'll pause for a second while you guys figure that out. So I'm hoping that kids remembered that the square root graph was this one, the middle one. And then it's going to get moved. And this part here is, remember the high-vo, horizontal on inside, vertical on outside? Notice the 2 things that are the vertical things are this and that. Okay, so that's a vertical reflect. And the other thing on the outside is a down 9. And it seems like those things make sense. Like they do just exactly what you would think. Whereas this is counterintuitive. You would think that would go to the right 6, but it actually goes left 6. Okay, now just a little advice before we take this little quiz here. I'd like you to think through, if I put in on an XY chart, if I put in the number 2, do you know? Well, I'm going to actually pull the plug on that one because I just did it in my head quick and it didn't work out nice. You know, you get to pick whatever numbers you want. So I know you would have picked 2 and then gone, whoop, that didn't work. So instead, I'm going to pick 3 because it's going to work so much nicer. And put it in here and see what you get. I'm going to pause for a second while you give that a try. Okay, hopefully you were thinking 3 goes here, and then I got 6 plus 3 is 9. Square root of 9 is 3. And then this makes it negative 3. Goes with the negative 9 here. Negative 3 and negative 9 makes negative 12. So 3 comma negative 12 is our point. Is there only one point in this graph? Of course not. We get to pick anything we want. And I would put in a few more things. But again, I'd be careful. I'd make them work. Like I'd use negative 2. On purpose, I kept thinking of things that go right here. And I thought, well, if I put in 0, that doesn't really work real well because the square root of 6 isn't real nice. So then I thought, I wonder if I could make that 6 get smaller. Oh yeah, I could put in a negative for my x. So negative 2 would work pretty well. If you did put in negative 2, you'd get square root of 4 is 2. Make it negative is negative 2. Go with the negative 9 then. Makes negative 11. And so on. You graph enough points, connect the dots, you get your graph. Okay, now let's see if without any help here, how you would do on a quiz of 1 and 2 are just tell which direction the thing moves. 3 and 4 are actually sketch the graph. All right, we'll give you a few minutes to try those top 4. Okay, what I was thinking that you would do is you'd say write 5 here. Then you would say this is up 1. Notice that we trust this. Plus 1 seems like it's up 1, and it is. This one may have seemed like it would move to the left because that's where the negative numbers are, but you don't trust things on the inside, so it's actually to the right. All right, this one, the square root of x, you would have found a few points like you stuck in 0, I hope, and then you probably got 0. Square root of 0 is 0. And you probably put in 1 and got 1, 4 and got 2, 9 and got 3. If you put in any negative numbers, hopefully like you put in negative 1, you would have said DNE does not exist. All right, we only had to have 4 points, so we'll stop at 4 there. And if I actually graph them, here's 0, 0, here's 1, 1. Here's 4, 2, and here's 9, 3. And look at that, it's making that nice graph that's slowly rising. That's your classic square root graph. And I'll put in my points maybe in a red here to make them really pop. And there. Okay. Now how about this one? On this one, you can pick any points you want, and these aren't that picky because absolute values, you can do any number, whereas square roots, only certain numbers work nicely. All right, so here I could have put in, for instance, 0. If I did, I get absolute value of negative 3, which is 3. Then I make it negative 3. And what if I put in 3? That'd be pretty smart because 3 minus 3 is 0. And once I put in a 0, it's the absolute value of 0, and negative is 0, and that's all 0. So 3 comma 0. Okay, next I could put in, how about like a 4? Now you might be thinking, I picked different numbers. That's totally fine. So 4 minus 3 is 1, absolute value of 1 is 1, and then a negative on the outside makes it negative 1. All right, I'm going to start graphing this thing. 0, negative 3 is a dot down here. 3, 0 over 3 up 0. It's right there. 4, negative 1 is down here. Ooh, I'm sensing a V shape here. That's upside down V shape. And think about it. Absolute values are V shapes. This means that it's been vertically flipped. So it's an upside down V. And it's been moved to the right 3. And if you just connect it here, would you agree that that's a V shape that's been moved to the right and been flipped over? Totally makes sense now. Now I would have lost credit on the test because I didn't give 4 points. Maybe I should just put in 1 more. So let's say I put in 5. And 5 minus 3 is 2. Absolute value of 2 is 2. Then I make it negative 2. Okay, so there is your little quiz. Now, just a quick reminder, what is the lesson for today, server? Well, it's pretty much review, because this is just so important. We need you to be able to graph things like this, and you have to be able to pick some points to put in. And so we'll practice that, and then I'll get to the things that are kind of new down here. And then your homework is a worksheet and a little Schoology quiz. So anyway, bottom line, let's have you try this one right here. Give you another minute or two. Act like it's a test question. Test is coming, not like tomorrow or anything, but when it comes, it'll have questions like this. So, all right, I'll pause for a second while you give that one a try. All right, so I'm going to put in 0, and I'm going to get square root of 1, which is 1, and then this makes it negative, so -1. I'm going to put in 1, and then I'd have square root of 2. Well, it's not like it doesn't exist, it's just not really nice. So I'm going to choose to strategically pick 3, because I hope you know that the square root of 4 works nicely. So 3 going in works well. Square root of 4, but then make it negative. So that'd be -2. Now let's put in, what are there some other strategic points? How about an 8? What if I put in an 8? I'm just leaving a gap because my numbers are kind of big. So if I put an 8 here, 8 plus 1 is 9, square root of 9 is 3, then make it negative, -3. And how about, let's go with square root of 6, no, square root of, yeah, 16 works pretty nice. So then I'm thinking if I want it to be 16, then I want this to be 15. So putting in a 15, and then the square root of 16 is 4, and then I make it negative, -4. They just have to graph the points. 0, -1, 3, -2, 8, 1, 2, 3, 4, 5, 6, 7, 8, -3, and 15, -4. Yeah, so it's like way over there. Oh, this is one of those graphs that goes like this. But you might be like, I've never seen that before in my life. Well, think of it as a square root graph that got shifted. Which ways did it get shifted? Well, yeah, it got shifted 1 to the, what is that, to the left. Oh, so I just never put in -1 in my graph. -1 would have been smart. -1 goes in, and then you get 0, and that's kind of the missing point right there. And now this square root, you can see it's been moved over and it's been flipped. Now, kids, this is the key moment. If you can make points like this, awesome, but you're really not going to be good at this unless you can also look and see what it should look like. You can't just blindly trust your points. So you get, some kid is going to probably get a point and they're going to screw it up, and the point will be like up here. And they'll be like, well, how am I supposed to connect that? Does it like look like that? I mean, so if you mess up one of your points, you have to be able to look back and then say, okay, this is supposed to be a square root, which generally look like this, except it's going to be moved to the left and vertically flipped. And that's what the blue one is. It's been moved to the left and it's been vertically flipped. Okay, we've got a few more practice problems there that you could do if you wanted to, but let's get to the new stuff. What if they gave you these points? Well, anybody can graph those points, server. We've all been doing that for 15 minutes here. What if you gave you these points as the new function compared to the original function? Well, could you look at this original function and figure out which one it is? Is that the absolute value one? Is it the square root one? I mean, what is it? My advice to you would be to actually just make an XY graph like this and roughly put in the dots for the original one in one color and the transformed one in another color. All right. Now, if you've got the technology to pull up some graph paper real quick, that would be smart. You can put a sticky note down in Notability. There's a way to put a sticky note down that's got graph paper on it. That would totally work. I would recommend putting this on a graph. Give it a shot. All right, so here's me attempting to graph these points without graph paper. -2, 4 be about there. -1, 1, that would be about there. 0, 0, that's about here. Over 1, up 1 is about there. Over 2 and up 4 is about there. Now this is, like, I gotta really be careful here to make sure that I am aware, is this a V shape or is this a parabola shape? And now that I'm looking closer, it's definitely a parabola shape, not a V shape. Okay, so that was the original one here. Okay, now I'm going to do the new one in blue. And that's -2, 6. It's a little higher than it was before. -1, 3. Oh, I see what's going on. 0, 2, 1, 3. Do you see what's going on yet? I see what's going on. If I just connect these dots, I got another blue shape. It's just been moved up. Now, could you have seen that without the graphing? I bet you could have. Look, these original Y's, I should have actually showed you first that the X's are exactly the same, but if you look at the column of X's, here, let me do that. If you look at the column of X's, the X values were exactly the same here and here. The X's didn't change a bit. It's just the Y's, which were here and here. What's the difference? Every one of them was 2 higher. Okay, 4 turned into 6. 1 turned into 3. Wait a minute. They weren't all 4 higher. They're all 2 higher. Sorry about that. They're all 2 higher than they used to be. So, how could I write that as a function? Well, if the original was y equals x squared, maybe I should make it in black because, or at least gray, because it goes with this black function there. Y equals x squared was the original one. Then the new one here would be y equals, and what would make it move up 2? Because, you know, look at the blue one, it's up 2. Well, it'd be x squared plus 2. Look at that. I was able to figure out what the equations were just from a whole bunch of points. My advice to you is to just graph them. It's so much easier once you see the graph to recognize which function you're dealing with, if it's a parabola or an absolute value or a square root. All right, so graph them, and then you'll be able to write these equations a lot easier once you got them graphed. All right, last piece of advice for you for today. Let's say that you get a function that's given to you in a picture like this, and you have to write the equation for it. Well, right off the bat, first of all, you got to figure out, is it the square root? Is it x squared? Or is it the absolute value of x? Or I guess it could be the simplest function of all, y equals x, which, by the way, is a straight line. So clearly that one's out. Okay, curve like that. I hope you know that one's out. That one is the little ramp that goes up slowly. Oh yeah, the absolute value, this one is a V shape, so it's more curved than that. So that leaves me with this one. Well, that's the parent graph. But do you see that this one has been changed? It's not just y equals x squared. Everybody take a second here. Give it your best shot. What do you think the equation is for this? And I'll give you this point just because I know it's sometimes a pain to like try to look up on the screen and figure out what that is. That's 4, 4 right there. All right, write the equation for it. And I think we have y equals x squared, and I think I know, I'm absolutely positive that some of you guys are going to have forgotten something. So I'm going to say x, and then I'm going to say plus 4. No, that would move right 4. I know it seems like it's moving right 4. Use minus 4. Because remember, the stuff on the inside is always different than what you think. And then this is squared because it is a parabola. And then it's also moved up 4. So I'm going to put a red plus 4 here. And some people think that's the final answer, but other people remember what? Say it out loud if you know it. What's missing? The negative. Very good. That right there is a really easy to forget little number there. Okay? Because this thing has been flipped upside down. He's not going up to the moon anymore. He's going down to negative infinity. Okay, so there needed to be a negative in the front. Could have said f of x instead of y. Sure, that'd be fine. All right, so I think the newest and weirdest thing was these. If you get a 2 sets of points, and if advice works for you, just graph both of them. I really feel like you'll be able to see what happened once you graph the two things. You'll realize what parent function it was and where it's been moved or transformed. All right, you guys, there is a worksheet which has a few of each kind, and then there's a little Schoology quiz. And by the time you come tomorrow, I will have talked with your teacher to let you know in class whether to do the Schoology quiz or not. That's all I got for you for today.